All right, folks, it's Bass Action back in action here. On this page of notes, I'm going to go through two things. I'm going to go through a discussion about the discriminant on the quadratic formula, and at the bottom of the page, I'm going to go over how to graph a quadratic when it's given to you in standard form. You'll notice that I've already filled out this page of notes, so you're going to probably need to pause, but I thought this would make it a little bit more efficient for us, a little bit quicker on the video. Okay, so let's jump into example 1 here, talking about the discriminant. Okay, so up here, example 1, the discriminant. The discriminant is specifically just the part underneath the radical. And the value of knowing the discriminant is it helps us understand what our graph is going to potentially look like and the types of solutions, meaning where the graph is going to cross the x-axis, what we're going to get. So I've broken this down into the 3 major categories that we consider. And then the first column here, we're going to look at when the discriminant is something positive, so it's greater than 0. What's going to happen when it's positive is that we're going to end up with 2 distinct real solutions. So what we need to imagine is that if we knew this value under the radical, we would have some number plus or minus some positive square root. Maybe it's a perfect square, maybe it's not, but it's certainly a number that we know divided by something else. That's how we get these 2 distinct real values, and it's going to give us these 2 points right here on our graph. So I just gave you a sample graph of a quadratic crossing the x-axis twice. Then down here, I went ahead and I gave you an example so we could actually visualize how this is going to work out for us. So I've got a quadratic, and this one I wrote it so that it would factor. And of course, when we factor this, that gives us these places where it crosses the x-axis. Then I went ahead and I've calculated my discriminant for us. Remember, it's just the part under the radical, not the square root itself. So that means that I have my b squared, or a 9, minus my 4ac. Simplifying that out, I get a 25. So here's a positive discriminant. You can see it crossing the x-axis twice. Now let's take a look what happens when the discriminant is negative. So if the discriminant is negative, less than 0, what we will end up with are 2 imaginary solutions. So our graph will either be a downward turning parabola below the x-axis, or it could be an upward turning parabola above the x-axis. Here's an example. X squared plus 4. We know how to graph this. We know it's just a quadratic that's been shifted up 4, so we've got that. We can see it never crosses the x-axis, so we don't have any real solutions. Real solutions would mean it's crossing the x-axis. And then I've calculated the discriminant. My b squared, there's no b value, minus my 4ac cleans up to a negative 16. So here's an example of what that 2 imaginary solutions looks like. The next one is if our discriminant turns out to be equal to 0. That means that we're going to have 1 repeated solution, and this one is often difficult for students to picture. So what that means is that our quadratic sits right on the x-axis, either opening up or potentially opening down. So here's a quadratic. This one is going to factor nicely. It should factor into, this is a perfect square trinomial, factors into 2 matching binomials, and we can see that we get that same 0 twice. And when we calculate the discriminant, it matches this idea we're talking about. Our b squared, 6 squared, minus our 4ac gives us a 0. So hopefully this helps you kind of visualize what this means, this 1 repeated solution and this discriminant, and then what the graph would potentially look like. Now, down here at the bottom, I've worked out a whole bunch of stuff for an entire quadratic, and I just want to talk through this. So for starters, when you are given a quadratic, I want you to work with whatever form you're given. Do not try to convert it into what you consider a more useful form. Every form has its own benefit. So in this form, we get something for free, and the thing that we get for free, that's kind of my own little lingo, the thing we get for free is the y-intercept, because that constant right there will give us the y-intercept. That's our freebie. So as soon as you see you have this form, you can automatically answer the question of the y-intercept, and you could plot that point immediately. Now, in order to graph this, what we're going to do is we're going to find our vertex. This one is the hardest one, I think, to find our vertex in. And what we're going to do, I've got it up here at the top for the vertex, we're going to do negative b over 2 times a. So I've already done that math. You can practice that. A negative 2 divided by 2 times this 1/2. So really it's just a negative 2 divided by 1. There's my negative 2. Negative b over 2a only gives you the x-coordinate. Based on that x-coordinate of the vertex, you can see down here, I've evaluated the function at the negative 2. So I went through and I did all that algebra to get the y-coordinate to put in. That meant I could plot that point. Now, as soon as you get the vertex, you can answer a lot of things. You can answer the question about the axis of symmetry, which is just the vertical line that's going to pass through that vertex. And we can also then start to even think about what the range is going to be. We also understand the max and the min at that point, and we might even feel comfortable to answer whether it's increasing or decreasing. So based on that vertex and plotting that, and knowing my graph is opening up, I know that this vertex is going to be a min. So I could immediately recognize it's a minimum of a negative 3 at 2. Again, I could write the equation for the axis of symmetry. Since I know that my graph is going to be opening up, I immediately know that that's the min. The range has to be from that y value up to positive infinity. And depending on how good you are with visualizing the graph, we can even recognize that on the left side it'll be decreasing and on the right side it'll be increasing. So those are all things that you can answer pretty quickly. The next thing that we're going to do is we're going to calculate our x-intercepts. So for my x-intercepts, remember, I'm just going to set the function equal to 0. So what I did is I did that down here. I chose to complete the square because I feel pretty comfortable with that. So I moved my 1 to the other side. I factored out my 1/2 because it was an easy number to work with. And then I just completed the square. Certainly you could do a method that you might feel more comfortable with, but I would challenge you to keep trying to work on that completing the square. I think it's going to help you. It's going to keep your numbers smaller for you in the long run. So I just stopped right here because at this point I can visualize the rest of the problem. Knowing I'm going to take the square root of each side, I'll have plus or minus the square root of 6, and I can move my 2 to the other side. Hence my answer up here for my x-intercepts. In terms of then the rest of my graph, I've got my vertex, I had my y-intercept that I reflected over, and then I did go ahead and just pick another point to give myself another one. You only need to do that if the problem asks you to find it, but I did go ahead and calculate another point there. And then the last thing that I'm going to talk about here is talking about this inequality. We want to know where our graph, where our function is less than 0. In other words, where is our function below the x-axis? And when I go and I find that on my graph, I can see that it's this whole chunk right here. So my answer is going to be the x values that make that happen. So I want to describe this x value. So it's just between these two x-intercepts, and you can see that's what I've written right there. So I know that this is a really fast overview. It's a very quick review of your Algebra 2. If you're not sure about any of those steps, pause, rewind, jot down some questions, and bring them to me in class.